Hello.
Hi. Okay.
Hi, Derek.
Hi, Derek.
Hey,
Hi, Camille. Hi, David. Hi, Shane.
Hello. How's it going?
Too bad, not too bad.
Hello.
Hey, Camille.
Okay, this goes here.
You see, Camille? I'm your human billboard today.
Nice.
It's just a shirt which wasn't top this morning. So I thought, you know what? It's Thursday, so
everyone.
hi, Zaggy.
I'm wearing chili cream, but it washed off a bit.
Oh, come on. We have the high quality shirt. It's not gonna wash off. Actually, when you wear it, it goes into your skin. So when you still have the chili cream logo on your chest.
Mine is next to the heart, the guild, so yeah.
1 second, I'm still going through the agenda. Kamil, I need a commit.
Yes.
This is issues. Okay. I think we are complete. Martin is not coming. He already told me he is busy today.
Yep. Just a heads up, I will also have to drop off halfway through.
Okay, don't worry. Okay, let's start. Hi, everyone. Let me remind you that by being here, we all agree to the GraphQL Foundation Code of Conduct and the Spec Membership Agreement. Let's start with a round of introduction. I'm Michael, and I'm the host today.
Yep. Shane from Apollo.
Derek from Apollo.
Yeah, Sergey from Monograph.
David from Undergraph.
Pascal from the
From the guild. What have you done, Kamil? What have you done to him?
I got to Camille from the guild, the guild.
the lifestyle. soon as you wear the shirt, you work for them.
Yeah.
Did you read the memo, Michael?
Oh, no. Okay, awesome. We have two things on the agenda for today. One is a couple of edge cases around inaccessible and internal I want to discuss. And then we have loads of discussion of satisfiability. So let's start with the inaccessible case. And I already talked with Martin about it, so I have his thoughts on that. Okay, so while going through all the algorithms, Glenn actually from the jQuery came up with these edge cases where you basically make a type inaccessible, which removes it from the union member here. And what do we want the behavior to be here, basically? There are a couple of things that we could decide for. I'm just out here. It's not only with unions, right? It could also affect interface implementations and things like that, where at runtime you technically could get this value from the subgraph, right? And so we could return here still user. So what do we want this to be? Like, do we want to handle it at runtime for more flexibility with schema evolution? Or do we aim for a more stricter composition error, right? Same as, by the way, with enums. And with enums, we had a discussion on that in any case, because we have to deal with that at runtime. Because when we merge an enum and be strict with it, there could be values that we don't expose yet that we have to deal with at runtime. Regarding this here, we could have a very strict one where we say, okay, we error out. Then we don't have any runtime errors because you have to deal with it in composition. We could describe it kind of like that. We could aim for, it's just a composition warning. We just tell the user, is that what you want? And then return null at runtime. Or there could be composition error, no composition error, and we just merge it and return null. Or we're throwing an error at runtime. So I see Derek already responded. Maybe you can.
So there was a question, what is the current behavior? So that's
Yeah.
the current behavior. Arguably, you could have a warning, I think. Because right now we don't put a warning there. I think it's driven primarily by the intent. So like when the user does this, what they're actually trying to do. And most often, I believe the use case was to evolve their schema in a safe manner. So basically start adding some shared type, right? So adding a new enum there that's only available in one subgraph and then putting some other ones there onto the other ones. It's how I would imagine that's the most common use case we saw, but that's the current behavior there.
The question is
Okay.
also a bit, do you know any runtime errors? Like, is this a common complaint that someone has runtime errors because they messed something up? Or is this something that occasionally happens?
People don't complain about this, so at
Yeah.
least I haven't seen it.
You won't get necessarily runtime errors because if you run everything through your router, the router is going to expose a schema which doesn't have those types and fields.
Yeah, but
So,
when you turn it from your resolver, what does the router do, right?
It's like when the subgraph returns something, yeah, subgraphs can return invalid data, which would throw an exception, right? Because we have an unknown enum value, right? Or unknown type. Those are errors.
David?
I think there's an important parallel to be made here with enums. So you can return an unknown value from an enum, in which case the router will respond that X is not a valid value of enum. And then if it's inaccessible, the router will not actually tell you what the value was in case it was sensitive. It will simply say received an invalid value for enum. So it's slightly different in those two cases. And I think you want to make something similar for something like this, where if, for instance, you've made a contract where you've removed the type that is part of a union, that union could, for whatever reason, be some kind of sensitive information. You want to make sure that that is not exposed at resolve time, at runtime. But at the same time, I don't think it makes sense to make it a composition error. A warning makes sense, but it should be something like it's handled with the inaccessible enums. It should be a runtime error, in my opinion.
Yeah.
Kamil?
Yeah, like having a composition error in that case will be too strict. It will be like super hard to actually get rid of inaccessible. I mean, it will block the development. So like I'm against of making it like strict and having like a composition error. And I agree with the current Apollo approach, which is, if you return something that is not valuable from the public schema perspective, you nullify it and like propagate the error if needed.
Oscar?
Yeah, so it is from the composition point of view, not necessarily an error. So the error behavior only comes through invalid runtime behavior. So let's say that you want to extend the schema and you say that you don't want to return this type until everyone supports it. Then it's actually a runtime error when you return it. So we anyway need a runtime error for the case, whatever we do, in case something like this happens. So we need to specify the execution behavior for this anyway. From a composition point of view, I think it should at least be a warning, because the composition would then at least tell you that you're going to be, you may or may not have runtime errors, depending on what you do. So to just silently say it's fine how it is, I think is wrong, because then you get a false sense of safety, right? The composition passed, everything is good, everything is green, we're good to go. That's not the case. You're only good to go if you do not return this value. So it has to be at least a warning, in my opinion.
Yeah, but by the way, that's also Martin's opinion, like that we should err on the stricter side and even do an error and be able to suppress the error. Like say, okay, because just because this is kind of, you want to make user inaccessible, and it might be that you don't know that it affects this type, right? Shane?
Yeah, that was going to be my question, because we can't just we can't just throw an error every time or a warning every time you use that inaccessible. So like the use case I'm trying to lock it down to what we're describing is like we want to or have a warning or possibly an error when you're using inaccessible, but it's through a non-intuitive or non-direct path from like the root or something, or like what is that explanatory definition, I guess?
I would say as soon as there is a side effect through inaccessible, we show a warning. So let's say that you make a type inaccessible and all fields referencing this type. That's not a non-issue, that's not a warning. But if you make user inaccessible and a union changes, then you have a side effect which you don't explicitly specify. You did not explicitly specify that this will result in an error. And there we can also do the more complicated variation of the enum validation. So we can say if an enum is only used in a certain direction, we may or may not print a warning.
And that's also the difference between these two cases, right? Here I say I want this enum value out, so I decide that this value should be out. So I expect here to be an effect, right? But here's kind of, I'm taking this type out, and there might be like several effects to other types because of that. The second thing is also when we mark a type inaccessible, we also expect like if this type, if this field here would return user, right? Then we would have a composition error. If this field is not marked. No, let me change the.
Oh, in this case, it's a composition error. Yeah.
Exactly. That's what I
Because
mean.
it's like you cannot resolve it directly.
Exactly, because we should then take out the kind of the field as well, because now the field cannot return it. So to have a warning if you have a side effect is kind of would be a good choice.
I mean, in the union. Sorry, Shane, go ahead.
I agree that this is a great way to describe it, is like when there was a side effect and like by adding the directive, you've changed the potential schema that clients were consuming. That's a great way of describing it. However, like comparing the previous and like the last, that implies that you have the previous, and like our composition spec is really focused on like, here's a schema, here's the current schema. I don't know about previous or next or any versions, just here's the schema. What's composite? So like what is the warning then in that case? Like what's the logic of describing like when we would put a warning?
Pretty much the same case, right? I mean, we look at everything and the side effect would just be there. If we have a warning on inaccessible, there needs to be a way to suppress it anyway. And again, it goes a bit into what that Derek said in the enum discussion, is what's the expected state? So is the expected state of the system in the end that the enums or the unions are different across different subgraphs? Or is the
across, got it, okay. Across subgraphs, okay.
Yeah, I mean, it's always only when another subgraph is involved. You know,
Yep.
if actually no, in the union case, it's not true.
Yeah.
Yeah.
In the union case, it's not true.
And also in the enum case, it's not true. So if you make, I would say it's also most likely only a problem in the output. So that means if you have an enum which is only used in the input, there doesn't need to be a warning because you can compile and you can execute all the possible queries. If a union is used in at least one position in the output, we have the same problem that we have with interface, and we have the same problem that we have with union, that you run into the runtime issues at some point. So the idea of flagging it as a warning, I think, is good, but there should also be a way to say, I don't care about this warning. And maybe you can even flag this with an additional directive or something. You say, I want to suppress in this case. I mean, you can just say, I want to suppress and suppress everything. Or you can say, I want to suppress this specific error message. And then you can just go on.
Yeah, this is, by the way, something we haven't concerned ourselves with is, I mean, we talked about error suppression and warning suppression, and that's also why we in the spec have a category like for validation. Is it an error? Is it not an error? And there is like, should we define in the spec how to suppress errors, or should we just leave it to the implementation? We could also make a note and say how you suppress errors or whatever is up to you, and what happens if you suppress is up to you. David?
My opinion on warnings and errors is that, sorry about the noise, is that if there's any way that the client can potentially fulfill its contract, it doesn't need to be an error, because you have potential to fulfill that contract. Once the contract is not fulfilled, that's when it becomes an error, in my opinion. Up until that point, it's a warning, because until it happens, it's not an error. You're basically promising that you're going to conform to the contract until you don't, at which point it can then be an error. That's kind of my stance on it.
Yep, I agree. I think it should be an implementation or a platform feature that if you can suppress it, it's not an error. It's actually a warning in terms of the spec. And if you want to suppress warnings, then that's a feature of each platform, composer, whatever it is, right? If I want to turn off specific warnings, or if I want to elevate a warning into it always throws an error, even though the spec marks it as a warning too.
Pascal?
I don't necessarily agree with that all errors. There might be two kinds of errors. So if you think about it, pre-merge validation rules have to succeed, otherwise we cannot merge. That's just fact, because we need the pre-merge validation to run. Yet maybe there is rules which we currently have listed as error because the error behavior is wrong, but you just don't care. So it's a bit suppressing. I'm not sure if we find rules that we can and want to suppress. It may be an specification thing. It may be, but I'm not sure.
Eric?
Yeah, so I was just wondering, it's flagging it as a composition warning, right? So hey, by the way, this may cause issues. Seems reasonable. At the same time, I would generally look at the user intent and how they're actually using it, because if this is used a lot, like as a means of evolving your super graph, you end up with a lot of noise. And if you have a lot of noise, people ignore that thing going forward. So that's you have to be very on how those are being used.
Yeah, but there's a difference, which is, yeah, sorry for chiming in here. There's a difference between a warning, because this warning will cause an execution error if you return it. So it's actually good. You either specifically suppress it somehow, or every composition tells you that, are you sure that you really not return a user in this search field? And it's like a reminder, and you can turn off the reminder.
Yeah, but I'm thinking though, like if you have 200 graphs, right, or something like that, 500 graphs, whatever, and you've added that extra inaccessible into one of the types, right? Because you want to evolve it, and it's a shared type across those 500 things, right? And then you keep updating those as you go. Means that you're gonna get a shit ton of those warnings until you actually resolve all of that. So that's I think that's a valid concern, and I think that would be actually good to have feedback from users. Well, I'm gonna call out Steven because they have a large graph, and I was wondering if they actually have concerns around those things. But yeah.
Yeah, I also put the question to Steven. I haven't yet a response.
He's in the call.
Hello.
He's not calling him out.
Oh, yeah. Steven.
How are you? Yeah, sorry I joined late. I'm still commuting here. So
Awesome.
yeah, it's a good question. Like is a warning, like what is the value of warnings? Because it is they can be ignored on one side, or they can be too noisy, which causes all warnings to be ignored. Yeah, in this case, I'm not sure. It's a good question, because I'd say at least having a warning, and maybe breaking, I think is what we'd consider, because it is dangerous, because the subgraph owner should be aware that it's going to cause an error if they're going to return a user. So I do think it should be at least a warning. But I guess the more conservative thing is to make it not allowed by at the start, because that's you can always move in the more permissive direction, and it's like easier, just and simpler sometimes, starting stricter.
Yeah.
And then maybe if we identify like specifically, this is a good way to allow evolution, then opening it up just with that specific case in mind, and then thinking of it as a transient state. So you get warnings, but it's intended that the warnings are going to last, very short amount of time, and like transient. Maybe it's like, it should be just while deploys roll out. So on the order of minutes and hours, and not days and weeks.
Yeah, so Martin's in the discussion that I had with Martin is that in this specific case, he would also say it should be an error first, because it should be like this will produce a runtime error. And then there must be a way to opt out and say, okay, I'm doing a schema evolution thing here. I have intended that.
Yeah.
And
yeah, that does seem reasonable. Then you're, it's because then you're allowing it for the specific, transient case.
yeah,
And so then it's clear that you're not intending this to be just a permanent state of your graph.
That's a good point. Now it goes into schema governance, right? But do you have any case in your graph where you want to? Is it always a temporary state when you have inaccessible on shared unions or shared enums or interfaces?
I mean, in our graph currently, this we don't have inaccessible, so
Right.
So it's not currently an issue.
Oh, you're in Federation 1.5.
Exactly. Yeah.
okay. So in either case, but I get here we are in these two brackets, kind of like a composition warning or error. From a rule standpoint, this is basically the same. We can decide. Let's formulate it as an error that can be opted out of. Like we are strict, and we maybe describe errors that could be suppressed. Like there are errors, as we agreed, that you cannot suppress, because then the system will absolutely not work. But this is a kind of thing where you could say, okay, I intend to cause a runtime error because I'm transitioning my schema to something. And I'm okay with this failing for a bit. One thing for the runtime behavior, do we want to just null it? Could be also a case, or do you throw this error to the end user? Kind of, okay, there's something unexpected.
Yeah, like option B plus D, where it's a composition warning but runtime error.
Okay. Note that down.
David?
You just said about suppression. Would that be blanket suppression or per instance?
So basically, the error would be caused here, and you would. So the thing that we discussed is more like per coordinate, and you would say for this type, I accept this error, and that means because like this type is causing this side effect, so you suppress for this type, and everywhere where it has this side effect, it would be suppressed.
Okay, per coordinate makes sense to me.
I was just actually typing up that as an issue, or maybe so we can write that down. So we can have an issue saying like error suppression, if that's a thing we're doing.
Yeah. It's another thing. Like we can always just describe it in this case. Like this was also like it's a shame that Martin is not here, but like this is something we have to think about. Do we want to make the suppression system part of the spec and describe it in this way, or should we just have it as an appendix? Like this is how we propose to do it. You don't have to, it's optional. You can also just run with all the strictness always. Because I don't know how breaking it would be to existing compositions.
I'm just scrolling through the errors, the validation rules that we have. And to be honest, I haven't found a single one that you could suppress with proper like behavior. So if I just look through the rules, it's like field. I mean, now in pre-merge validation, that's anyway gonna not work. But lookup. I mean, there's one that is already a warning. It's a lookup returns non-nullable type. Fair enough.
Yeah.
It's already a warning. You can suppress this one. But things like provides on a non-composite field, or we have just take any of the validation rules that we have. Invalid graph code, invalid syntax, type kind mismatch, type definition is invalid, and all of these rules that we have written, none of them really is suppressible. It's only one that's the warning. I mean, I can go through it again in more piece, but
so you're saying we call them explicitly out, which are suppressible?
Yeah, because now if we say that we can decide if we want to have it in the specification or not, but the behavior, what we do with suppression, could be a platform thing, so that you, for example, can ignore it and say, I never want to see this in, for example, in the Apollo Studio thing, or however it's called. You can say that you want to suppress this warning and you don't want to see it because this is actually something that you already know about. And then this could just be a feature of the platform. But I wouldn't make an exclusion for, because just make the spec more complicated. Like these errors you can suppress. It's one error that you can suppress. And then we can also suppress warnings. So it's like it probably should be a warning, and you can suppress warnings somehow.
And should we? Okay, if we talk about suppressions, then we probably also should put in that you can promote a warning to an error.
Yes.
If you.
Yeah, exactly. Yeah.
And also the throwing in error at runtime or returning null at runtime. It's, in my opinion, it's clearly a runtime error because it's a behavior that you haven't accounted for. That means that if you look at it from a data graph perspective, it's wrong. Like it shouldn't be null. You have to notify the user that there is something that he's not allowed to see, otherwise the data is invalid. So definitely, in my opinion, definitely a runtime error.
+1.
Okay.
Agreed.
I vote for the composition warning plus the runtime error. I think router shouldn't change the behavior of the underlying response. If there's a shitty response, well, that's an error, right? If it doesn't conform to the spec. And suppressing errors seems wrong to me on a philosophical level. So, like, if it's a word that this may cause an issue, I'm fine with that, yes.
Okay, that's good. I write it up, and then we can integrate it in the spec. Awesome. This is the first agenda item. I'm passing over to Pascal, who has more on satisfiability.
Yeah, so we had a very quick sync this week about satisfiability. I have to lower my hand. You didn't miss much. The only thing that we said is that we look through our cases and see if we find some kind of common rules that could be specifiable. Let me share my screen quickly. First, do not disturb. Let me share the screen. So I've looked through through the test cases that you have sent me, Carmen, and generally, do you see my screen?
Yes.
Okay. So generally, I see that there is one major rule, which essentially is what satisfiability describes, right? Is you have insufficient key fields to move. We have to, by the way, agree this meeting on what we want to call this: move, transition, whatever you can come up with, between subgraphs. And this basically is that, for example, here we have a viewer and we have two subgraphs. The one subgraph has a type user and we have a viewer, and the other subgraph has a type user and has user by ID and name. So we have one lookup, we have a key, we have a lookup, we have a key, and we have this data field which is returned. Now, when we query viewer name, we actually first fetch this field, and then the executor will say that we have to resolve name, so we have to get to this subgraph, but we cannot get to this subgraph because name doesn't exist here. And in this case, we need ID and name to resolve name as the key. And this is like the classic, in my opinion, when I look at the test cases, the case which is tested in all variations. And there's some kind of special case of this when we talk about require, because in require, in the end, you also have the problem that you're missing keys for a move or a transition or whatever you want to call it. But it's more a specific problem with required. So only, it's not that you try to resolve comments and you cannot go to the other subgraph because you're missing some keys. It's only because of this specific require, you actually require to have name as well, which you cannot resolve. So under the hood, I would say it's more or less the same rule, but it's a bit more specialized with require. It could be two separate rules. So we could, for example, have this rule for the move just for the, as in the formal specification. We also define algorithm, a named algorithm, which we then can reference in the other subgraph, in the other rule, and we can say, actually now call the insufficient key fields to move between subgraphs rule, but with an additional key, something like this. With the current feature set, I'm not sure if we are missing anything. I've seen that there are a few things which there's tests for, but which should actually not be a problem. So override, for example, should be caught in post-merge phase. So there is a satisfiability check for this, but it's not really a satisfiability error. It's a post-merge validation error. We shouldn't need to check in satisfiability for this. Non-shareable should also be caught in post-merge. So we know that theoretically everything is already possible. So everything should be shareable, that should be shareable, and so on. And then the completely different keys or keys that do not match or deep nested hierarchies and whatever is something that is actually also just this rule. You don't have enough information to go to this graph. And this rule could also like do multiple hops at the same time. So when we specify this out, we can say that there must be a key to go to another key, to go to another key, and then you get the data back. Yeah, so any obvious observations that you have with this information already? Is there anything that you want to add to this? Do you think that there's something, some basic rule which satisfiability should check for, which is not covered by essentially you cannot move between subgraphs because keys are mismatched?
I would have to think about it. Like regarding the thing you mentioned that like the override could be outside of the satisfiability. I'm not so sure, to be honest, because it drives how the query is resolved.
Yeah.
I mean the fields.
I agree, but if I'm not mistaken, we always talked about override, like override. I know that it exists in the, for example, in Federation, the supergraph document, but it wouldn't have to, because you can just remove it from the subgraph because it doesn't exist anymore. There should be no way to resolve this field.
Oh, you mean in that case? Yeah. Then yeah, that's true.
Except
If we do it.
Except for the use case that folks asks about the what we call progressive overrides. I believe Wondergraph calls it like feature flags also like that. So like, it's not like, you know, just shift the traffic to another place. It's only shift part of the traffic. So shifting all the traffic, yeah, you can do that. But if you shift only parts of the traffic based on some flags or whatever,
Yeah, I would
kind of need it.
I would say in this specification at the moment, we are also not talking about interface objects. And on a priority list, in my opinion, the progressive override or feature flags is below. If we even specify it, it's below the interface object. So I think we should focus on the coverage that we have now. And the reason why I think we should make this still rule based, even though it's essentially one rule and one special case of this rule. I think interface objects and all the other things probably can build on top of this, because with interface objects you will have the same core validation logic as well. At some point in time, you need to make a move, and this move can be validated with these directives, right? With these algorithms. I think there's a core algorithm in satisfiability, how we can validate that a move between a subgraph or a certain coordinate is possible. And the rules then just use this core algorithm. And as I said, this can be as complicated as we want it to be. It just needs to be understandable. We don't care about caching, we don't care about optimizations, we don't care about anything. We can visit the same schema graph if we need to until the sun dies and the universe is cold and dark place. Theoretically, doesn't matter, right?
So if I understand correctly, if you want to, let's say, validate insufficient key fields as its own validation, right? You want that, or?
Well,
because sorry, I will interrupt you. Because if we do that, then the case with provides might not be covered.
Yes, that's one question I actually have about provides, which we have to talk about as well. I would say we specify a core algorithm for how we visit the schema graph, and there will be another core algorithm which will be used by many of the rules in satisfiability, which essentially says, is this possible to be resolved from another subgraph, or is there any, or can we not? I don't know about the shape of it yet and what parameters we have to pass in there, but we'll see. And then we have specific rules. And I would say this is just the field, this name, it might be wrong, but we can just say, this is just when you have two types and you have a shareable field. And now you have to make a move between one subgraph, between one schema to another schema. And this rule does the same thing, but more specifically for the require use case. And then we maybe have another rule which only cares about the provide stuff. Does that make sense?
I guess.
We'll see.
We would have like satisfiability and then, I don't know, provability or some sort.
No, it's all included in satisfiability. Satisfiability will be like merge. If we look at merge, let me go to merge. In merge, we have actually one core algorithm at the very top, which does the merge. 1 second. So here, this is how the schemas are merged, right? And then basically, when we try to merge types with the same name, right? We go through. We have basically a switch case based on kind. So we have one algorithm which will visit all of the type system member in the schema, everything that's possible. And on each field, we can then verify that this field is satisfiable in all the different cases. And there we can pass in a path, we can pass in all the source schemas, we have the context of everything if you want, but it should be that we have a validation rule which covers everything. That's just one idea. So we just visit everything, and then we see what the validation rules do. The validation rules could be run. I don't know about the shape of the algorithms yet because I haven't written or coded them. But theoretically, we can run. We could run in each validation rule over the whole schema. We can have one core algorithm, and then we can execute each validation rule for each field, for everything, for each argument if we want to. So we'll see.
Yeah, I think calling those separate rules is fine. Makes it simpler than trying to do everything all at once. One additional validations I see is the actual inconsistent abstract types. So inconsistent union or interface implementations across the subgraphs. So that is actually that is one of the validations we got. And
so you mean that?
So if one graph, I have a interface I, right? And in one graph I got implementation A, and another one I got B, right? And you have a query that is returning an interface, right? So how do you actually know what you can return there? It's actually not. Or interface A and then type A and B implements that one, right? So this is the, if you want to see, 1 second.
Stop my ID quickly.
Yeah, so you can see those the tests are all spread out, but the one that I actually were talking about is actually in this validation errors file that I posted in the chat. It shows the difference that that you have a query that's shareable, how you actually get from one to another.
Are we talking about non-intersecting runtime implementations?
Yes. Though this is another validation rule, yeah. Not a satisfiability rule.
In case you are not using it in a shareable field, it doesn't matter. In case you use it on different fields, you just will get subset of what is allowed in the current subgraph.
Yes.
So it is more about composition.
Yes, it is satisfiability that actually when you actually, so it's in some cases this is valid to have that, in other cases it's not. So
yeah, if we could specify this case, that would be great. So if you can, you can do it in just in an issue if you want. Just add a few examples for it, or the example if there is only one case.
No, it also applies to unions.
yeah, we have a test for interfaces and unions. Yeah.
Yeah, if we can add this to an issue, that would be good. That we have to cover this. Yeah.
Because I was looking at the other errors, and they are kind of they are related around keys and mismatches. So mismatching the keys, non-resolvable keys, all that stuff. But that's covered by the general rule that you mentioned that the keys don't match, right? You cannot jump between subgraphs.
Yeah. But why is this a satisfiability issue?
Sergey?
Yeah, I have another question not related to the different shareable. Mostly it is about the keys. Like there is a couple of unique situations which could happen to keys, and it's actually quite tricky to validate that things. Like we know that there is exists something like resolvable false on the keys, but also we have keys which are not explicit ones. And do we want to allow not explicit keys? And do we want to allow keys which are spreaded between different subgraphs? So like you have a subgraph which has keys consisting of 3 fields, but in order to get all that 3 fields to conduct a jump, you need to visit all 3 other subgraphs to get the key values and then conduct a jump.
Yeah, so there's two things to unpack here. So in the composite schema, we don't have non-resolvable keys. We only have resolvable keys. And we also, it works different in terms of each key maps to a lookup. So this is just doubly bookkeeping what we have here. It's a discussion point that we still have.
That's actually not correct. So the key does not map one-to-one to lookup. We wanted to do that originally, but we went away from it, right? So one lookup can potentially map to multiple keys.
Yes, then we have to probably, actually, good point. One thing that we have to have a validation rule for is
The lookup and the key, right? That there's actually a valid key from a lookup. Yes, that's
a fusion, a composite schema specific validation rule, which we probably have not covered yet. So let me add this to the spec real quickly, because otherwise we'll forget. Validation rule.
So this is so to add more background on it. So the reason why we are not doing that, so we can allow like multi level lookups, right? So like a GitHub lookup by org
Yeah.
name. That's primary use case for that. So that's why they don't exactly map one-to-one.
Yeah, but for all keys, there needs either one or a combination of lookups that can be matched.
Yes.
So that's basically what we do.
Yep.
Therefore, there can be there is no non-resolvable keys. We don't have an entities field. We don't use external as for example Federation does. So we always have a very explicit way how to look up things. Now, for yeah, so this is about the keys. What was the second question? About the first one was about non-resolvable keys, and the second
implicit and explicit keys. Like in Federation, even if the entity do not have keys defined, but in case you have field ID and it is not external, you could use it to jump, but it will be only one-way jump, only from the subgraph.
Yeah, so there is also no implicit keys. All keys have to be in a lookup. You can maybe count node as an implicit key, but actually it's still explicit.
Because it's explicit as well.
Yeah, I mean, you can think about it as less explicit than having a dedicated lookup for all of the types. But it's the node field will always resolve by ID. So therefore, as soon as an interface a type implements node, and you have a node resolver, then you also can have a resolvable entity there. So there is no concept of non-resolvable or implicit keys. Now about the other thing, about the jumps, where you have 3 subgraphs and you have a fourth you have 3 schemas and you have a fourth schema where you require in the key all of the fields from the other schemas, and then you basically have to hop to the other schemas first to collect all of the data. That's actually a use case that is used in Federation with current Federation customers a lot, and we have discussed this use case. the idea, or how a lot of federation customers use or abuse, depending on how you want to call it, the keys, is to get data from one subgraph to another subgraph. So I need to have some data, so I define a key, I hop to the other subgraph, and then I get the data in. And this is something that we haven't really touched on, because you can do it the same pattern with the composite schema stuff, but it's something that is a problem, which is probably, the keys are probably not the right solution for the problem. You probably want to have some kind of data requirements, but that's future stuff. We don't really care about this yet. Yeah. So, yeah, David.
So the problem, one of the problems that I foresee with this, so my personal opinion is that entity keys should always be a handshake. That's not currently the case. You basically define a target, and if you can satisfy that target, you can go there. And the reason I believe it should be a handshake is because in one graph, if you imagine you have a field like ID that another graph is using as a key, and then someone, so you have no key directive in that graph. To me, that says potentially I could remove this key, remove that field without many consequences. But in reality, the consequence is that it was relying on that key to satisfy a jump to another entity. So it's not telegraphed that the importance of having that field defined, because it's implicitly being used as a way to jump to another graph. So my opinion on this is that it should always be an explicit handshake to kind of telegraph the behavior that you intend.
Yeah, but does that scale when you have to declare all the keys on all the subgraphs? I mean, if you have 200 subgraphs and now you have one subgraph which requires, let's say we have user and we have name defined in a few subgraphs for a read optimization as a shareable field, right? And now, as soon as I want to add a subgraph with this key, I'd have to declare this key on all of the other subgraphs as well, if you want to have it as a handshake.
Yeah, I understand the scalability issue, but if you were to remove that key because you're using it implicitly, it's not clear to the person or the team making changes to that graph that the function of that field is more than what meets the eye. So, okay, I understand the concern here with scalability and the fact that you might have 200 subgraphs or whatever, but you're not telegraphing explicit behavior, which itself is like, it's a trade-off, right? Do you want to telegraph explicit behavior that and potentially?
Yeah, the thing is, the key is the wrong tool for this, because what you're basically saying is that if name is declared here, then it should also be part of the key, right? That's the thing. So when you want to move with ID name from here to here, then it should be declared as key as well.
It should be a handshake, in my opinion, yes.
Yeah, but that doesn't work, because that's not how the key is only specific to your subgraph. And in the first version of the composite schema didn't even have keys.
Yeah, I understand it's a target, but like I said, there's undefined behavior here, but we can just discuss this another time. It's not so impressing.
Yeah, let's do that. So your thing is that you want to doubly bookkeep the keys across different subgraphs. Or you know what? Can you specify it in an issue? Then we can read through it, and then you can add it to one of the workgroup agendas, and we can have a look at it.
Certainly.
Okay, that's good.
Before we move on.
Yeah, it just a small addition on top of David's thoughts. Basically, it doesn't mean that we should add this key to every possible subgraph, but it is more a question of, in case there is a possible jump between two subgraphs, it should be visible from schema where you could jump. Like in case you have key ID and you it is possible to jump with ID and name, and you have name, then there should be a key with ID and name that this jump is visible, that it is really possible to jump to another subgraph which either has ID or has ID and name. It is more of this question, because it's actually will make satisfiability check more simple, because you could just see immediately, is it possible to jump to this subgraph? Does I have key fields for that subgraph or not? In case something is implicit, then you anyway need to dig through it. You couldn't collect just like metadata by going through all schemas and see which jumps are possible.
So it's, let's say we have a product subgraph, it would be about having this key defined here, even though we don't have a lookup, right? Because you can move from products to users via this key. So you're about having this in the two places where you can jump between.
Yes.
Okay. Yeah, let's put it in an issue and discuss it, because keys have a slightly different use case in the composite schema specification than in for example, federation. It could be that a component is missing, where you can explicitly specify a field as movable, but yeah, that's something that we can discuss another time, I believe. So one question before, we already 1 minute overtime, but as I have Carmel in the call, you said something which was interesting before, provides. How does provides affect satisfiability? Do you actually have to go through all of the different possible paths to provides? You do, right?
Amen.
So when there's a way to go there without provides, and the way you can go there with provides with external, you have to basically verify that both cases are possible. Is that the correct?
David was first, so I let him speak.
But no, please go ahead.
So basically, like every field needs to be accessible from every root, from every query path, right? And by query path, it means the actual query, right? So if you like, I don't know, select products, and then from the products you select reviews and blah, 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 and then you have this like field that is like, you know, either provided or not really, right? So like the way I did it is you have one supergraph that is like public schema that users can query, and then is the internal structure. So when you navigate from the root to the leaves, you check if, you know, if this path can be executed in the like private / internal structure. So the way I deal with provides, it's just like, it's yet another graph within a graph. So it's like a subgraph that can, you know, like a subset that can be, that has no conditions. You just like visit the field, and then you just jump, you know,
Could we think
deeper and deeper, and then you collect all the fields.
Could we think about this in the way that so in the composite schema specification, this can only ever happen when you have external on the field. So if you have external fields, you will have provides. There's a direct link between these two directives. External is not used for anything else.
We also have it, Pascal, for keys, right?
Yes, but that's implicitly provided through the lookup. There's no key. External is always linked to a provides or to an implicit provides through a lookup. Lookup always provides the keys.
Yeah, but the like the type itself within a graph is always available. I mean the key fields. Like no matter if it's a lookup or you take it from any.
There's a case we've discussed this, where you have just imagine you have product by ID, product by SKU, and you have actually it's something that we can also move this to another discussion. But essentially, depending on which lookup you go through, you may have access to the SKU, or you may have access to the ID. But you may, when you go through SKU, you might not have the ID. You know what I mean? So
yeah, I get that.
That's also what I mean. Like theoretically, it could be that you have two lookups. One is by SKU, one by ID. If you're going through the ID field, you might not have SKU.
Yeah, so it's an implicit provides that we have on the lookups.
But that would be like a breaking change for a polar federation, because whenever you resolve a field, you have access to all its field, a type, then you have access to all its fields.
Yeah, but
So-
it would be external, right? In this case.
No, not really. I mean, so in Apollo, you have the entity, right? And then you have the entity calls, whatever you call it. And then if you fulfill one of the keys, you get access to all the fields there. So even if, let's say you have two set of key fields, and you enter with let's say through ID, but then the other one is ID and name, you have both. Like you just, you check the requirement of one set.
It's actually simpler to think about like ID and SKU or something, right? That's a good example, right? It's the assumption is even though you have two different ways to look it up, it still results in the same data, right? Points to the same object, which you have access to both of those, and kind of like you have a database table, right? And you have the primary key and whatever unique key. So whether you look it up that row by ID or SKU, you get the whole object back. Kind of thing.
Yeah, I think we discussed it 2 meetings back. My argument was more like back then. I don't know if we have had it resolved. What if you have two read optimized tables? One table has a lookup for ID, the other table has for SKU, but they don't have.
I mean, you don't even have to be technical. You can just say that only certain things are stored as SKU, certain things are stored as ID. They're both on the same type, both are nullable. You have either or, right? So
yeah,
maybe you have also both, but it's actually two completely different things that you store. But it's a good thing. I think that's something that we have to discuss. Also, Kamil, I don't think it's a breaking change because we are more strict, not less strict. So it would just be that it's routed differently. So it wouldn't be a breaking change. It would just be a change in behavior. But it's something that we have to talk about because I think that there we still have some deviation between how we understand the thing. Because for me, provides is pretty clear. You come through a path, it provides, then you have access to the external fields. Otherwise, you don't have access to the external fields. So that's something that we have to be clear about. Yeah, David?
I have, it's a slightly convoluted, but it's an illustrative kind of example of something. I'm going to paste it in the chat if you wouldn't mind putting it on the shared screen. If you could paste it in that document, perhaps, just for now. And essentially, you have a provides that's, so you have a recursive object here, and you're providing only the first layer, but that means the second layer is not provided. So this is, even though you're providing object ID, because it's recursive, the next layer is unprovided. So this is not satisfied. In fact, you can't ever satisfy this because you could always go one layer deeper than could be satisfied.
That's a good case. Because it would have to be here, right?
Yeah, because that's no, even here, no, because it's recursive. You can never, this can never be satisfied. Because you can always go one layer deeper than you're able to, it's infinitely deep, right? And it's external, and you have to satisfy all those externals, but you can't because it's infinite.
Yeah, but isn't that valid?
It isn't what valid, sorry.
If I say on the object provides by ID. I mean, the problem is probably
But the problem is that you're saying it's valid on the path entity.object.id. But what about object.object.id and object.object.object.id, etc.? It's not, it's unsatisfiable.
Yeah, is this so this is I see. Okay. Yeah, it's two different types. I understand.
I think if you put it there, if you put it on 5954 like that, then it is satisfiable, yes. Because it will, each recursive instance would then provide its own layer
ID.
deep. Yes. But if you put it only on the layer above, then it's never satisfiable.
Yes.
It's just kind of food for thought, really.
Yeah, that's a good case. For whatever reason, my VS Code is super slow. Sorry about that. Okay. So about the provides thing before, let's open an issue quickly that we don't forget our provides words together with entities. That's something that we have to agree and have a clear understanding. Let's do that in the next meeting. To verify provides, I thought about it in satisfiability. Essentially, is if I run into an external field, I basically have to check if any field in the path has provided this, and if not, it's not satisfiable if I need it, right? That could be a way how we could specify it. I know, I mean, currently I've implemented it differently, but if you think about it, when we go through the graph and we have access to a path, right? Then we can say that when we hit an external field and we need an external field for a move from one subgraph to another subgraph, then somewhere in this path of fields.
The external field needs to be a subset of the path you're currently on. The provided path. It has to be a subset of the provided path.
Yes, but I'm talking about the actual execution or visitation path. So I'm in field, I don't know, entity, address, street. So I'm in street. Now in this object, now I need another field to jump from one to another. So I check on all of I see that this field is external. So now some field in the hierarchy has to have a provides directive. It's not how you would implement it because it's very costly to walk up, check, and walk down again. But it's something that's very easy to specify. A field in the hierarchy has to specify the provides for the external field I need.
Yeah, sorry, that's what I meant. I meant something in the current path that you're on, somewhere further up needs to have provided it. Yes.
Yeah. Because then the validation rule is probably quite okay. So was good. Only half the two people are here. Then let's take this to the next meeting.
Cool. Thank you.
Awesome.
Okay, bye-bye.
Goodbye.
See you.